welcome back to the channel again. Today we will solve the 10th question of July Leetcode challenge. So our question is flatten a multi-level doubly linked list. Now what we have a doubly linked list and we have some parts like a tree. Means some nodes, or at some nodes we have a child and that child is connected to a linked list also. If a child is null, then it is not connected. If it is storing some value or some address, then that child or that address must contain one more linked list. Now same linked list will have same properties, means the child linked list will also have same properties like this. Now we have to flatten this. Now what we have to do, we have to combine this. Suppose these all are the child of 3, so we have to append these 7 8 9 10 after 3, and 8 has 2 childs also, 11 and 12, so we will append these both after 8. So a sequence what it will be, first this 1 will come, then 2, then 3, then 7, then 8, then 11, then 12, then 9, then 10, then 4, then 5, and then 6. So this is how we have to flatten this, or this is how we have to make one linked list of using these many components or these many linked lists. We have to compress this into a one linked list. This is how we have to solve this question. Now we'll look at that how we will solve this question. Now for understanding the question, we will take this as an example. In this is our main linked list. So what we will get, we'll get this as our input. Now what we have to do, we have to flatten it. Now first of all we will manually flatten it, or first of all manually we will do that. How we can do this? So what we have to mainly do, we have to append these values after this. So what we can do, we can break this and we'll connect this. Now at the end we will connect this with this. So now our cycle will be like this. So our values will be first 1, then 2, then 5, then 6, then 7, then 3, and then 4. Now if you look at 6, same thing we will do here also. We'll break this, we'll go further, and at the end we will add this. So this is how we will connect. Now our path is like this, first here, then here, then here, then here. At the end we will go till here to here. So our path is sorted. We have to go from first to the leaf, and then we have to append. So this work is similar to inserting a node into a linked list. Now here I have taken a singly linked list. Now if we have a doubly linked list, same thing we have to do twice. We have to do this thing, and first of all we have to initialize the previous, then next. So we have to do with these same things which we have done with one pointer. We have to do that thing with double pointer. So first of all we will understand that how we will do using these all things. So first of all, if this is our example, now we will initially get this. So now we will traverse each and every node. Now suppose if we are on this node, now what we will do, we will check that the value or the child, if it has any child or not. Now if it has any child, suppose this have 5 as a child, or this is a child named 5. Now after this what we will do, we will iterate over whole the linked list. Before iterating, what we will do, we will first consider this as its next, 2 as its next, and we will store this value, this 3, into a temp or a temporary variable. Now same we will do, or we will traverse. Now at any instance if we find a child, we'll do the same thing. First of all we will call this function again after we are coming on this. So now this will be treated as the main, and this will be as the child. So what we will do, we will use recursion, and in the recursion first of all we will take this as our parent. After this we will take this as a parent. Now at the end we will take this as a parent. and we will consider that more such linked lists are there or not. If more such linked lists are there, then we will append one by one all the values. Means first of all we will insert these values into this. So we are going from bottom to up. So first of all we will insert these values into this linked list. After this we will push back, or we will insert these value to this. So first of all these values will be inserted into this. So a big linked list will be formed of child up to a parent. So we will form a child up to this parent. Now after that we will insert this, so we will get our linked list. Now we have more child. Suppose we have one more child or one more child. So first of all we will push back this, then this, then this, and then at the end we will push back this. So this is a simple operation of just insertion between a linked list. So this is how we will solve this question. So now for proper understanding we will look at the code, and with the help of code we will understand properly. So this is the code for the solution. So first of all, here I have initialized a pointer ptr in which I will store the head of every linked list whenever we will come or we will encounter a new linked list. So whenever we will encounter any linked list, then we will iterate over its values. Now suppose if we does not found any child, then we can directly return the head. If we found some child, then what we have to do, that is the main thing. If we does not found, we will go on next and till the end. When we will find the null, we will return. Now what first thing we will check, if a child is there or a child linked list is there or not. So in this case, on first iteration we does not found any child iteration or any child linked list. After that we found one at 2. So what we will do, first of all we will initialize a temp which will store the address of this next, or which will store this arrow, means the third, or this will be stored in temp. So in temp the value is 3. So at the end we will point this 3, or mainly it is storing some address, but I am considering it to be a 3. Now after that one more pointer will be initialized. Now in this node's address will be there. So in temp 2 the address will be there of 2. Now after this the next, means this we will consider, or next means we are just trying to find the value of this, means we are just trying to connect it. Now if the next is a child, means now we will traverse this whole linked list. So we will again call the same function with the child's ptr, means now this will be considered as our head. Same thing will happen with this head. Now suppose this whole iteration happen. Now what will happen, if next, this ptr's next, what it is null. In this case it is not null. So what we will do, we will take its next previous, means we will store its previous. One more pointer will be there which will point this to. What we will store, we will store this previous as temp 2, means this 2 or this temp 2 will be storing as pointers next. Now pointers next after returning, means when this pointer is called, means this whole linked list or this child linked list is traversed. Now at the end we will have a pointer on this. Now a temp 2 will be on this and our pointer will be on this. Now what we will do, we will initialize its previous to this. So we will do this thing with the help of this. If this is the end node, then we does not require to do anything. In this case it is not the end. So what we will do, we will initialize its previous as this, and we will initialize the child or the child of this ptr, means the child of this will be null, or every child will be null of this linked list. Of this current ptr we are considering the main part, which is ptr, which will be pointing this. So we will consider this as null PTR. After that, what we'll do, we'll iterate over all the values. Now what this part is doing, this part is doing the iteration of next. So first of all, this will be removed, this child will be removed. So before the child will remove, this value is already there in the temp. So this PTR will iterate over all the values, and at the end this PTR will be on the next. Means at the PTR we will store this value, this 8 will store in the PTR, or the pointer which will store the last node. Now we'll check that if temp means the temp which we will store is there or not. If it is there, then we will store its previous, means the previous of this will be stored as PTR. Now what will happen after the first iteration, this will be removed, or this will be redirected to here, and this node will be removed. So after we do this all things, this will be removed, and one more thing will happen. This will be pointing this, and this will be pointing this. So after first iteration or after first recursion, this will be formed. Now when the head will be there on this linked list, same thing will happen with this also. This will be removed, so we'll remove this, and we'll form one more linked list, or we will form this, and at the end this will point this, and this will point this. So we will create two pointers such that these both are in relation with someone. Now when we are on this, then this will be called, or this will be treated as a head, or this will be treated as a parent linked list. Same thing will be happen with this. This will be treated as parent, and this will be treated as the child, or this will happen. So these all values, now this 12 will be directly linked with 7. So for that we are doing this thing. So for this thing we have done this. Now at the end, how a relation will look like, we will go from this down, left, right, bottom, right, top, right. So at the end we will get a new linked list which will flow over all the sub linked list or all the child linked list. So now we will submit our solution. So this is the code for the question. So now if we submit the solution, we got correct answer. And if we see more details, so it is faster than 97.09% of the C++ submissions. So it is fastest, and memory usage is not that much because I am using too much pointers and recursion is also used. That's why the memory is not that much efficient. So this is the solution for the question 10 of July Leetcode challenge. So if you want to see more such question explanation, you can subscribe my channel. Thank you guys for more such content. Like, share, comment, and don't forget to subscribe.